This week, we're going to be taking a look at exponential functions. Okay? Today, I think we're going to focus mostly on what we call growth functions. Then later in the week, we'll also look at what we call decay functions. Right? So I showed you guys some examples. Let me graph those again. Out of the three graphs up there, we could just use the colors. What two did we say were exponential type of functions?
Red and black.
The red and the black one. Yep, those are exponential. Now, not everything that curves is exponential. Okay, I could put up another graph like this one in pink. Now, the one in pink curves, but it's not exponential. That's a little bit different graph. Right. But the red and the black one, those were exponential. All right, so how do you tell if something is exponential? Well, if you're looking at a formula, it has to look like what's in that box. So what's in this box, that's kind of like our y equals mx plus b for this kind of graph. Okay, it's called y equals ab to the x. So on your guided notes where it says and then you got some room, you're going to write an exponential function is a function of the form y equals a times b to the x. Now it is important, this a and b, they can't just be any numbers you want. Okay, there are some restrictions, and I think you have them written down. The a can't be a 0. Okay, we can have numbers other than 0, but we can't have a 0. And the b, I think you guys already have that one written down too. I wrote it up here kind of like a short way, and then down below it, which is what you have in your guided notes, I wrote it out the long way. So it says b has to be bigger than 0. That's what that top part means. B is bigger than 0. So b is greater than 0, but it can't be the number 1. Okay, so there's a couple examples, and I'm going to type those in on the calculator so we can see them. But these are examples of exponential functions. Now, I haven't really taught this part yet, but one of those is growth, and one of them is decay. Does anybody think they know which one would be which? So there's the y equals 3 times 2 to the x, and y equals 4 times 1/2 to the x. Anyone think they know which one of those is growth?
The 3 times 2 to the x.
Yes. This function, they're both exponential, okay? But this one is the one that's going to curve up as you go to the right. Okay, let's type it in. So let me clear out these other ones. Just 3 times 2 raised to the x. Now let's just check and make sure it fits the definition. Looking at what I circled in red, what number there is a?
3.
The 3. And it says a can't be what number?
0.
Can't be 0. So is that 0? Nope, that number's fine then. And then what number here is the b? 2. Is 2 greater than 0 and not the number 1? Yeah. So that fits the definition of what's called an exponential function. So when you hit graph, it's going to look pretty flat, and then all of a sudden it's going to start to curve up to the right. This one is decay. Okay, this one that I just circled in green. Does anybody know what number, or have an idea what number there would make it decay?
The half.
The half. Yep. Because you have a half here. That makes it decay. Right? Now let me show you that one. 4 times 1/2 to the x. All right, let's check it. The a is 4. That's fine. And the b is 1/2. Yep. has to be bigger than 0, but it can't be the number 1. So 1/2 fits that definition. All right, let's hit graph. So this one is not necessarily an exact mirror image, okay? Because I have a little bit different numbers. They're close, the 3 and the 4. If they were both 4s in front, then they would be perfect mirror images. But these aren't quite. If I make this one like a 9, you might see it a little better that they're definitely not mirror images.
So basically, it's got to be the same multiple.
Yeah, you have to have the same number in front. I think you'll be able to see now that you can tell now they're definitely not mirror images. At least over the y-axis, they're not mirror images. So, yeah. All right, any question why those are what we call exponential functions? All right, so notice what stayed the same. The y stays as y. The x stays as x. Those two things never change in the final answer. The only things that change are the a and the b. All right, so we're going to look at writing these kinds of functions 3 different ways. Okay, and I don't think this part's on your guided notes. No. So it's just the kind of examples that we're going to do. We're going to write a formula. Basically, if I give you a table, then we're going to look at doing some graphing. Okay, but we're going to do it on paper. We're not going to do it with a calculator. And then the last thing we're going to do is compare 2 graphs to each other. So we'll go through kind of each type. All right. What does this word mean? It says
not straight.
Not straight. Anything that curves. Okay? Linear. Think of the word that it has in it right there, line. If something is linear, that means it looks like this. That. Okay, straight line. If something is nonlinear, it means it has a curve to it. Exponential functions are one type of graph that have a curve to it. What format is this one? Y equals 3x plus 2.
Y equals mx plus b.
Right, that's y equals mx plus b. So what I want to do is look at something that's linear and see if we can figure out what the pattern is. And then we'll do something that's exponential. Let's see if we can figure out the pattern. All right. So what I did is I picked, and again, this part, you guys can just watch this part. I picked some numbers for x. I did -2 to 2, and I just went by ones. Okay. If I plug in -2 for x, what's 3 times -2?
3 times -2 would be -6.
And what's -6 plus 2?
4, -4.
-4. Okay. How about if I plug in -1? What's 3 times -1?
-3.
-3, and then plus 2?
-1.
-1. Okay, we'll do one more and then I'll just show you the rest. Let's plug in 0. What's 3 times 0?
0.
0, and then plus 2?
2.
2. Okay. So what I did is I plugged in all of these different numbers for x, and then I wrote down the answer that I got. The way that you figure out if something is linear or nonlinear, look at the pattern in the y's. What do you do to get from -4 to -1?
Plus 3.
Right, plus 3.
And then
Now-
plus 3.
And then from -1 to 2?
Plus 3.
Plus 3. How do you get from 2 to 5?
Plus 3.
Plus 3. It's always a plus 3. When you make this table, anytime the pattern is adding the same number over and over, that's what a table looks like if something would be in a straight line. You add the same number over and over. And I think we looked at that earlier in the year. So as x goes up by 1, say we did +1, plus
Let's
1.
write it down.
I don't think there's a spot there
Yeah, no.
to write that down, so that's okay. So as x goes up by 1, you're adding a number to get to the next y value. Okay, it doesn't always have to be 3. It could be plus 5, plus 5, plus 5. Okay, it could be a different number. Okay, so any question on that pattern? All right, now let's look at something exponential. All right, so I've got 5 numbers that I picked, -2 to 2. And I'm going to plug them in one at a time and see what I get. All right, so what's the first x value they want me to plug in? -2. So we're going to do 2 times 3 to the -2. So this is what we talked about last week. When you have a negative exponent, what does that negative need to do?
Divide. Addition.
Okay, so yeah, it's something with division. Can somebody tell me where does a negative exponent end up? When, like, if you, say, made this into a fraction like that. Where does that 3 to the -2 end up?
On the bottom.
It ends up on the bottom. And what happens to the exponent when you put it in the bottom?
Does that become positive?
Right, it becomes a positive. So this is going to end up being 2. And then the 3 to the -2 goes to the bottom. And what does it turn into when it goes to the bottom?
5 to the power of 3. Oh, no, 6 to the power of 3. No. 6 to the power of 2.
So it's right now the 2's in the top. And what we just said, the 3 to the -2 is going to go to the bottom. And the exponent becomes a positive.
So it would become a positive, stay as positive.
So what would you put right here?
-3 to the second power.
No, not negative.
Would you solve for the exponent?
No. Maybe we should have done the warm-up. So remember, when you have a negative exponent, okay, like let's say 8 to the -5. When you have a negative exponent, that means to take whatever you have and put it in the bottom of a fraction, but make the exponent positive. So if I move 8 to the -5 to the bottom, what's left in the top? Nothing. So what do I have to put there?
1.
Right, I have to put a 1. And what would be in the bottom?
1 times 8 to the power of 5.
Right, you already have a 1 there. And then it's 8 to the power of 5, which is just 1 over 8 to the 5th. Right? And we wouldn't worry about 8 to the 5th doing it out, because that's a big number. All right, so that's what happens when you have a negative.
When would you solve for the exponent?
If it asked us to, or it was small enough, we could do it out. All right, so now let's look back at this one. So what's going to end up in the bottom here, based on what we just did?
3 times 3 to the power of 2.
Yeah, 1. So the 1 was already down there. And then 3 to the power of 2.
Is it
Well-
a negative sign?
Nope, positive 2, because the exponent went to the bottom. And then what's 3 to the second power? 9. And what's 9 times 1?
9.
9.
9. So there's the first one. 2 9ths. Okay, let's look at the next one. Okay, we're going to plug in -1 for x. 2 times 3 to the -1. So that's going to be 2. And what's going to happen to the 3 to the -1?
Becomes a positive.
The -1 becomes positive. So what ends up in the bottom?
2 times 3 to the power of 1.
Well, 2's in the top, so we took care of that. So this is separate from the 3.
So 3 times 3 to the power of 1.
So 3 to the power of 1. And what's 3 to the power of 1? 3. All right, so that one's 2/3. Okay, sometimes it's harder to see the pattern when you have fractions. If you have a hard time seeing it, keep going in your table till you don't have fractions, and then the pattern is going to be easier to see. Right. 0. What happens if you plug in a 0 right there? What's 3 to the 0 power?
0.
What is it?
1.
Yes, 3 to the 0 power is 1. And what's 1 times 2?
2.
2. Now let's plug in 1. What's 3 to the first power?
3.
3, and then times 2.
6.
So that's 6. And now let's plug in 2. What's 3 to the second power?
9.
9. And what's 9 times 2?
18.
18. Okay, so now we have our y values. The key is we want to see what the pattern is this time. Right. My advice would be, look at the ones that start that aren't fractions. They're going to be easier to figure out in your head. So 2, 6, 18. What can you add to get from 2 to 6?
4.
4. So let's check it. If you add 4 to 6, do you get 18?
No.
No. So then the pattern here is not adding 4 each time. Right, let's try something else. What's another way you can get from 2 to 6?
Times 3.
Times 3. 2 times 3 is 6. Let's try it again. What's 6 times 3?
18.
18. So yes, this time the pattern is multiplying by 3. So what was the difference between the one we did over here that was linear and the one we did over here that was exponential?
Addition instead of multiplication.
Right, that's the big difference. Addition instead of multiplication. If the pattern is addition, it's going to be a straight line. It's going to be linear. If the pattern is multiplication, that's when it's going to be exponential. So what I would do is on your guided notes, okay, that is kind of important to write down. I would put it where it says A is and B is. Don't write on those lines because we're gonna fill those in. But then right below that, kind of like on the dotted line, you could put. Let's do this. I want you to write this down. So in a table, if x increases by 1, and actually I pretty much wrote it right there. Let me see if I can just shorten it. In a table, if x increases by 1 and y is multiplied by a number, actually I'm going to say by a constant, because constant means it has to stay the same. It has to be times 3 each time, or times 4, or times 5, but it's got to be the same number. So if x increases by 1 and y is multiplied by a constant, this is exponential. Okay, so that's important. So in a table, if the x value goes up by 1 each time, and the y value is multiplied, that's the whole key, multiplied. Let me highlight that, that's important. Not added, it has to be multiplied. That is exponential. All right, so any question on the pattern that you're looking for? Okay, looking for a multiplication pattern, not an addition pattern. I mean, we did look for addition patterns, but that was earlier in here. Okay, now we're doing multiplication. Does everybody have that written down?
No.
All right, so now I need to tell you what the A is and what the B is. Like, there's a way that once I tell you, you can look at all the numbers in that table right there, and you can figure out what the A is and what the B is in that equation, y equals AB to the x. So when you write an equation in exponential form, you need to figure out these two numbers. I'm going to tell you how you do it right now. Okay, so what's the A? So where it says A is on your guided notes, you want to write down A is the y value in the table when x is 0. Okay, it's the y value in the table. So you're going to read a number from the y row when x is 0. Right, so let me pull up a table to see if you can tell me what the A value is. So we go to a table. You don't have to write this down yet. Okay, all I want you to do is look at that table. Tell me what the y value in that table is when the x value is 0. Yeah? 2. So all you have to do is find where the 0 is, and then read the number that's right below it. So if we were writing an equation for this problem, which we're going to in a minute, the A value will be 2. It's the y value right below the x value of 0. Okay, so that's how you find the A. What's the other letter in that equation that we need to figure out? The B. The B is also easy to figure out, and that's going to relate back to what I showed you right here. The B value is what you multiply by each time. That's the pattern in your table. So the B value is the number you multiply by each time. So I think in the problem we just did, it was times 3. So the B value in that problem would have been a 3. Remember, it's got to be multiplied. If the pattern is adding each time, that's not what we're learning this week. Okay, so it's got to be multiplied. So now you should have everything above the dotted line filled out on your guided notes. And the next thing we're going to try is example 1. Does anyone need me to go back so they can copy anything else down? Okay, one thing, I'm not sure if I pointed out or said to write it down, but where this box is on your guided notes, you also have the same box. You should fill in where there's an arrow coming from the y, you should put stays as y. And where there's an arrow coming from the x, you should put stays as x. And then you have a spot for the two letters, the A and the B. You can just put those in. But yours looks exactly like that. I don't think I mentioned to write that down. So let's try example 1. So example 1 says rightly move for the function. You guys need to fill in the table. Okay, I didn't give you those numbers to fill in. Okay, so when we're done, I'm looking for something like this. I want you to tell me the two numbers that are going to go in those boxes. First thing, can someone just tell me what's the name of the letter that goes in the first box?
A.
A. And the letter that goes in the second box?
B.
B. Okay, so look back at your notes. What are the directions for finding A? What does it say? A is what?
Can't be 0.
Okay, that's what it can't be, but what do the directions say for how to find it? A is
The value of y.
the value of y.
Of the function when x equals 0.
Yes, so it's the y value in the table when the x value is 0. Yep. That's your A value right there. So what do you do if there's no 0 in the x row then? Well,
It won't be the A.
I'll always give you a 0. So there'll always be a 0 in here somewhere. In more complicated problems, no, there might not be. So maybe a little harder. Okay, but I'm always going to give you a 0. So that's your A. And then what about the B? What do the directions say for finding B?
Which multiply each y value by as x increases by 1.
Right, let's just check here. Are these x values going up by 1 each time?
Yes.
Yeah, so that's perfect. If the fraction confuses you, then don't start with that one. Start with the next one. What are you multiplying by to get from 1 to 2?
2.
We just have to make sure that that's the same pattern all the time. How about from 2 to 4?
2.
Yep. And how about from 4 to 8?
2.
Yep. So we are multiplying by 2 each time. So what does that mean my B value is?
3.
What is it?
2.
2. That's the number I'm multiplying by each time.
But it says it increases by 1.
Yep, so the x is increased by 1 each time, so that's good. So now we just check what we multiply by each time in the y's. So maybe not the best example because A is 2 and B is 2. Those two numbers don't have to come out the same. Okay, that's just kind of a coincidence that they did. So if you write your final answer, you don't need to put boxes around the numbers. You could just write 2 times 2 to the x. And remember, these 2's don't have to be the same, just the way it happens. All right, any question on that one? All right, now, what if I gave you a table like that, and I just asked you, is this exponential? What would you say, yes or no?
Yes.
Yes, how come?
Oh wait, no, never mind. It's not because in the bottom, the y, it's adding and not multiplying.
Right. So if I ever gave you a question and just said, is the following table exponential, yes or no? The answer here is no, because you are adding in the bottom, not multiplying. Yep, good. All right, so let's see, do I have another example? Yep. So let's write a rule for the function. So again, you guys have the table. You can fill in the numbers. So the x's are -2, -1, 0, 1, 2. It doesn't really matter what I start with, as long as I go up by 1s each time, and I give you a 0 in there. The method that I taught you will work. If I don't do that, then you wouldn't be able to solve it with the method I taught you. Okay, and the y's are 1/9, 1/3, 1, 3, 9. Okay, so first thing in the table, check to make sure everything is set up right. Do the x's go up by 1 each time? Yeah. So that's good. All right, now we got to check the y's. Let's look at 1/3 and 1. What do you multiply 1/3 by to get 1?
3.
3. Yep. What do you multiply 1 by to get 3?
3.
And what do you multiply 3 by to get 9?
3.
Okay. And if you multiply 1/9 times 3, you do get 1/3. Some people just have trouble or it's a little harder looking at the fractions. So I would say look at the ones that aren't fractions. All right. Now, if I just asked you, is this linear or exponential? Which one would you say?
Linear.
Why?
Exponential.
Why would you say linear?
Because all of them look the same.
So we got to be a little bit more specific when we're saying linear versus exponential. There's
Isn't it be exponential since it's you're multiplying?
yes, it's exponential because of the multiplication in the bottom. What would happen in the bottom if it was linear?
I'd be adding.
Yeah, adding. You can also add negative numbers, which would really be like subtracting. So if it's any kind of adding or subtracting in the bottom, that's linear. Multiplying, exponential. Yep. All right. So now let's see if we can write our formula. First, without filling any numbers in, can somebody just tell me what the what's the type of equation? What does it look like?
Y equals A times B X.
A times B, yep, raised to the x. And what are the two letters that we need to figure out?
A and B.
A and B. Which two letters stay the same?
Y and X.
The y and the x stay exactly the same in the final answer. So we can put those just like that. All right. Can someone tell me how do you figure out A?
Just wouldn't it be just you take the from where x is 0 and where y is 1, so a would be 1.
Yep. You look where x is 0, and it's the y value in the table when the x value is 0. So in this case, it's just a 1. Times. And what's the b value?
3.
3. It's the number that you multiply by each time in the bottom. And that's your answer. So it's y equals 1 times 3 to the x. Right. And if I type that in, let me just type it in right here. 1 times 3 to the x. Is that going to look like a straight line when I draw it? Or is that one going to curve?
It's gonna curve.
Yep. So it's going to be, you can watch it, it kind of levels out, and then all of a sudden, once it gets past the y-axis, look how fast it curves up. It's never vertical, but it's as close to vertical as you can be without being vertical. It's very steep. Any question on that? Put in one other one. Let's put in, let me do it in blue. 1 times, let's say 1.3 to the x. So I just put in a smaller number. Instead of 3, I did 1.3. What do you notice the difference is between the blue one and the pink one?
Different slopes.
Yeah. Which one curves up faster?
Pink.
Yeah, the pink one. The pink one starts to curve up a lot faster. The blue one's still curving up. It's just taking a little bit longer to start curving up. And that's what this number does. In case we hadn't really said that clearly yet, this number controls how fast it's going to curve up. A big number here makes it curve up very quickly. A smaller number, like 1.2, 1.4, something like that, makes it curve up slowly instead of quickly. That's what that number does. All right. So any question on how to look at a table and figure out the A and the B and write your formula from the table? All right, so that's the first thing. All right, next thing. Let's see, we're going to graph an exponential function using a table. So what you're going to have to do now is you're going to have to make this table yourself. Okay, I'm not going to give you all the numbers. I'll give you a suggestion of what I would plug in, and I would follow what I'm suggesting. You're going to plug in -2, -1, 0, 1, and 2. You're going to plug in all those numbers yourself. So that's what we were doing right when we did this part right here. Well, we did it somewhere. When I went back and we did the warm up again, because we were having a little trouble plugging in those negatives, but that's what you're going to have to do. You're going to plug in all these numbers yourself. Once you plug those numbers in, you're going to fill in all the y values. And that's what I tried to kind of review in the warm up. Okay, so remember your rules for negative exponents. If you have a 5 to the -2, that means you can put it in the bottom as 1/5 squared. So it's just an example to try to remind you how to do negative exponents. All right, so basically steps 1 and 2, that's make your table. Step 3, well, step 3 is continuing the table. Fill in the XY column. So if you look at your guided notes right below step 4, you'll see what I'm talking about. There's going to be a column that says X, Y. Okay, so steps 1 through 3, make your table. Step 4, do your graph. Okay. Another reason I have you guys pick those points is because if you go a lot bigger than 2, your graph is going to go up bigger. Because these graphs curve up very, very quick. So if you pick an x value like 6 or 7, you're probably going to be in the hundreds or thousands. It's going to be too big for you to graph. All right, so those are the 4 steps right at the top of the guided notes on the back. Yes? Yep, just sign up for me. Okay. Does everybody have those 4 steps?
No.
Nope. So I'll leave those up so we can still copy them. Oh, is it under there? Sorry, yeah, you can put that back out. So we're going to graph y equals 3 to the x. All right, so first step. What values did I suggest that you pick for the x column?
-2, -1, 0, 1, 2.
Okay. So those are going to be the x's. So in fact, we could fill those in right now for x. -2, -1, 0, 1, 2. Now, why can't I just graph those points? What do I need to find?
Y.
Yeah, I need to find the y. So in case your table doesn't have that, you should have a y at the top of the second column. Okay, what's the first number that we're going to plug in for x? -2. So fill in -2 for x. And what does 3 to the -2 turn into as a fraction?
1/3 to the power of 2.
Yep, perfect. And what's 3 to the power of 2? 9. So the first y value is 1/9. Is that a pretty big number or pretty small?
Small.
Yeah, that's pretty small, 1/9. Okay, what's the next x value we're going to plug in? plug in -1. When you do 3 to the -1, what does that turn into when you write it as a fraction? Yep, 1 over 3 to the power of 1. And what's 3 to the power of 1? 3. So that one is 1 over 3. Okay, I think once the exponents start to be, once they're not negative anymore, then it gets a little easier. Let's plug in 0. What's anything to the 0? 1. Let's plug in 1. What's 3 to the first power? 3. And my last x value is 2. What's 3 to the second power? How much?
5.
Not 3 plus 2, 3 raised to the 2. 9. There you go. So we got our table. That's the first 3 steps. What's the last step? Graph it. Now, 1/9 is a very, very, very small number. So when we go -2, 1/9 is like just barely above 0. We can't even really tell. Okay. -1, 1/3. All right, well, that's up a little bit higher. What's my next point? What's the whole coordinate? 0, 1. Okay, so now you're starting to see that curve a little bit. Okay, next coordinate. One, 3, and my last coordinate. 2, 9. So you can see what happened. If you went any bigger than 2, you'd be off the page. All right, and now just connect your dots. So remember, this part is basically just going to stay very flat. And then as it approaches right, that's when it starts to curve. And it keeps going. Keeps going in both directions. What do we call this point right here? Where it crosses the y-axis. Anyone remember the name of that? Yep, that's the y-intercept. So this number right here, the y value in the table, when the x value is 0, that number is really where it crosses the y-axis. All the time, crosses at 1. All right, any question on that? So that's really all there is to making a graph. You just have to make your table, use those 5 x values each time, figure out your y values. You can use a calculator if you need to, and then graph it once. So that was the second thing. Okay, so the last thing is comparing. So we compare to exponential functions. There's a certain phrase I'm going to want you to use. Right? So I'm going to teach you how to say it and kind of what I'm looking for. All right, let's graph. Okay, you guys don't have to. You don't have to graph this. I already did it on the calculator. I just want you to see these different graphs, and I want you to see how they look. So I'm going to graph 3 times 2 to the x and -3 times 2 to the x. I want to see what the difference is. Well, there's 2 to the x. Okay, you can see it's pretty flat, and then it curves up as it goes to the right. Then we could figure that out with a table if we really wanted to. Okay, that's 2 to the x. Now, I kept the blue one, but I also added in the other one. The red one is 3 times 2 to the x, and the black one is -3 times 2 to the x. Okay, so what do you notice? Let's look at, say, the red one first.
They're parallel.
Okay, so they look kind of like parallel. How about in terms of which one curves up faster?
The red one.
Yeah, the red one curves up a little bit faster. Okay. What do you notice about the black one? Negative 3 times 2 to the x. What did that negative do to the graph?
It goes down.
Yeah, it's like it flipped it and it made it go down. In fact, I can show you that. Because if I take this and I trace it, and I take this exact picture that I traced, and I'm going to flip it. Look what happens. It's exactly the black one. So what this negative does right here, it flips it. That's what that negative does. So we're going to talk about how do we write that down when I ask you to describe what the negative did. All right, so this is what you guys want to write down where it says comparing exponential functions from graphs. Well, first, let's look at the one where a wasn't negative. We'll do the negative one in a second. But the one where the a wasn't negative, okay, basically this is what happened. Let me trace over the blue one. And let me see if I can stretch this a little bit. Okay, I'm going to take this and I'm going to stretch it. All I did was pull it vertically a little bit. And notice if I do that and then move it up, it lines up perfect. So what that 3 did is it basically did this. The bigger the number, the more this happens. That's called a stretch. So it stretched it. We didn't stretch it that much. You can see now that one doesn't quite fit as good. It's too much. But that 3 causes what's called a stretch. So let's write that down. Okay, it didn't flip it because there wasn't a negative in the first one. Okay, but if the number is greater than 1, then the graph is stretched. Okay, an even easier way for me to show you that is if I take something that's a perfect circle and I stretch it vertically, what does it turn into? Yeah, it turns into like more of an oval. That's what's happening with these exponential functions when you stretch them vertically. They don't turn into an oval, but they're being stretched, and that's what I'm trying to show you. All right, so how do you write that down? So where it says written like, you guys want to fill out the part that's underlined. Vertical stretch by a factor of, that part never changes. The part that changes is what you put right here. You need to fill in the number in the problem, okay, whatever number they give you. So let's say you have this one. If I was comparing that one to this one of them is 3 times 2 to the x, one of them is just 2 to the x. I would say that this top one is a vertical stretch by a factor of 3. That's how you would describe it. So vertical stretch by a factor of, and then tell me the number that's right there. So what if I gave you one like this? How would you describe 5 times 2 to the x compared to just 2 to the x?
Vertical stretch by factor of 5.
Yes, this is a vertical stretch by factor of 5. That means it's been stretched out 5 times as tall. And what if I did that? How would you describe it now?
Vertical stretch
Vertical stretch by a factor, now it's 15 times as tall, so it's a lot taller. Yep. All right, so that's how you describe it when the number in front is a positive. So what do you do when it's a negative? Well, you still start out the same way. You just have to say one more thing because of the negative. So what happens if A is a negative number? If A is negative, that causes the graph to flip. So instead of looking like this, it looks more like that. Kind of curves down instead of up. All right, so when you describe a graph that has a negative, you're still going to say the same thing you said up here. Vertical stretch by factor of, you're going to have a number, but you're going to have to say one extra thing. And flipped over the x-axis. Okay, so the written like part, that's the part that's important. That's what I'm going to be asking you to write down. So the first part's the same. Vertical stretch by a factor of, write in the number for A. The key is whatever number you put here has to be positive. Okay, we don't use the negative number there. This is what you have to write down because it's negative. And really, you should have the word and. Kind of sneak it in there right there. Vertical stretch by factor of 2 and reflect over the x-axis. Okay, you only say this reflected part if the number is a negative. Okay. All right, we'll try 2 examples of that, and then that's it. Does everyone have both the written likes? So example 4a, it says compare the graph of, and you guys have a little bit of space, you need to fill it in, y equals 4 times 2 to the x with the graph of 2 to the x. Okay, whenever I ask you to compare, these two numbers will always be the same, 2 to the x and 2 to the x. They have to be. If they're not, you can't compare them. All right, so first of all, is the number in front of 2 to the x, in this case, positive or negative? Positive. So you're going to be looking at this case. How would you describe, or how would you compare those two graphs using what we just said on the other page? Looking for the written like part.
Vertical stretch by factor of 4.
Yes, vertical stretch by factor of 4. Perfect, that's exactly what you need to say. Why didn't we put reflect over the x-axis?
Because it didn't do that.
Why, yeah, this one doesn't do that because
It's not negative.
it's not negative. There's no negative in front of the 4, so we don't write that. So we just write vertical stretch by factor of 4. All right, let's look at this one. So compare the graph of y equals negative 3 times 4 to the x with just 4 to the x. Okay. No matter which case we have, can someone just tell me what's the first part of the words you write down that never changes?
Vertical stretch by factor.
Yes, vertical stretch factor of. Factor of just means how much of a vertical stretch. Okay, vertical stretch by factor of. And when we write that down, what did we say about the number that comes next? The number always has to be what?
Positive.
Yeah. Don't worry about it being negative. We're going to take care of the fact it's negative when we write this sentence right here. Okay, so vertical stretch by factor of what number?
3.
3. Perfect. So vertical stretch by factor of 3. And now what else do we have to write down because there's a negative?
And we put it over x-axis.
So and reflect over x-axis. So what you're doing is you're describing what this would look like if you drew it without actually drawing it. All right, that's it. Okay, any question on it? So it's a little bit more in the first lesson just because we're starting exponentials. Now some of what we do Tuesday, Wednesday, and Thursday will be kind of like review. So you're going to see some of the same stuff. All right, so homework is the 6.3, 6.4 part 1 worksheet. And remember, we'll have our test on Friday.